Hello guys, welcome to Lab Report number 3, end of August 2015. A lot of time has passed since the last lab report, and I think there are a lot of things, a lot of miscellaneous things that I could talk about, and I guess I hope that I will run a little warmer during the video. Right now I'm actually not in such a good mood, and I will start this one on a rather negative note. It's something that I really don't like. Normally, if I have negative feelings concerning anything YouTube related, I pretty much keep it to myself, because I think that people really don't want to hear it. I guess people want to hear positive things and solutions to problems, which I like to offer. But sometimes there are things which really bother me, and I want to talk about that before I come to anything technical today. The first thing is copyright issues. I know that many video or content producers in general are complaining about strict copyright regulations on YouTube, and they are pissed off that YouTube took down some of their videos because they used copyright material. I never had that problem, to be honest. One reason for that is that I do not really use any popular music in my videos. For example, sometimes I'll use some very a little strange music or self-composed stuff, like my intro. Some people like it, some people don't. And the reason for that basically is that I respect the copyright of other people. But I also want other people to respect my copyrights, and that is something that has been a bit problematic in the last time. Actually, I had to file copyright complaints to YouTube because people have been re-uploading my videos, and we're not talking about 1 or 2 times. I have filed 24 copyright infringement complaints to YouTube in the last 4 weeks. Several channels from different countries re-uploaded my videos. They tried to change the video format a little bit, and some of them made their own comments in other languages. While there also were copycat channels which simply uploaded all my content, re-uploaded it, and all that stuff has been taken down by now because I filed the complaints. And what I wanted to say is, please don't do that. And I mean, of course, if someone re-uploads my videos and makes a new comment or commentary in their own language, I could still see that as something of a service. But then re-uploading it and monetizing that without asking me is infringement of my copyrights. I can't put it any other way. So if you're planning to do something like that, then at least ask me before it. Maybe we can have some kind of cooperation. But I still don't think so, because I have no way to check if someone who made a Spanish translation of my videos has done that accurately, and then maybe wrong information will be inserted in the video and that I'm not even aware of, and that is something that I don't want. So please just don't re-upload my videos, even if you do it for a reason that you think is something good. Okay, this is one thing. The other thing is really, YouTube has the tendency to show the worst of people. I mean, all in all, I'm really a very lucky guy, because most of you guys out there are really great, are generous people. There is almost no profanity in the comment section, nobody is insulted, and so on. But then there are days like today where I really get up in the morning and I make the mistake of checking YouTube comments while drinking my coffee or something, and I read stuff like, oh, you're retarded, or this is bullshit, I don't know. People just, bringing up no arguments at all, but just insulting me, and for reasons I just can't understand. This is something that I don't take lightly. I mean, most of the time when something like this happens, I just delete the comments and don't think about it anymore. But today was a day where I actually had like 3 or 4 stupid comments in a row, and was like either people watching like 10 of my videos but then do not write anything constructive, but just have one complaint like I don't like the music or something. I mean, guys, seriously, I just don't care, you know? I mean, just pick the things that you like and leave me alone with the little things that weren't for you, okay? I mean, I cannot work all day to make your specific wishes come true. That's the next thing. And yeah, I don't want to go on whining about this, but just, you know, just so that you understand. When I got up in the morning, I really had a lot of energy, and I was planning on maybe finishing a larger project that I've been working on and really uploading something great today. But you know, if you read certain things, it's just like a kick in the nuts, really, and you lose your energy. You don't want to work for people like that, and so yeah, there is nothing great today that I can show you. I can show you a lot of things that I have been working on in the last weeks, but I cannot give you definite results on anything today, because I'm actually planning to make a trip to northern Germany, more specifically to the city of Lübeck, which is a couple of 100 kilometers away, and I will be gone for a couple of days to a week or so, and in that time there will be no uploads, I guess. At least I see something very special in Lübeck. Maybe I will make a spontaneous video about that. But yeah, okay, so that being said, let's come to something more positive and something more constructive. And the first things that I want to talk about are the things that you see on the bench right here. The first thing that I want to talk about are these wrenches that I have bought a couple of weeks ago. Some of you might have seen them before and maybe wondered why I wasn't talking about it, and the reason is that I'm actually not such a big fan of product reviews that are being made of products which are just brand new out of the box, because yeah, people unbox stuff and try to say something positive or negative about a certain tool, but have never used it. So what can they say other than, yeah, the material looks good or something like that? So that's why I took my time and actually used this stuff for around 2.5 months, which maybe is again not enough time to say if a tool is really of great quality or anything. But one thing that I can say already is that these Proxxon tools, it's a brand that is quite well known in Germany, but is, as far as I know, not made in Germany. I just can't imagine that, because the prices for these tools are just too low to make that even possible. These socket wrenches right here are of the 1/4 inch and 3/8 inch size, which is like a mid-size, you know, between 1/4 and 1/2. You see how I'm struggling with these inches things, because we normally don't do that in Germany. We have everything in millimeters. And that's also true for the nut sizes that you see here, of course. You know, you have like 19, 18, 17 and so on. And that's of course in millimeters. The only thing inch here is really the socket itself. You know? And one thing that you can say is that it maybe would have been a better decision to buy a 1/4 inch and a 1/2 inch set rather than a 1/4 inch and a 3/8 inch. But all in all, I still have to say that I'm satisfied with the quality of these tools. They are not very expensive. This set, for example, which has like the small 1/4 inch wrench, a screwdriver type wrench if you want, where you can put on these nuts for these typical hex screws, as well as an assortment of Torx, Inbus, Phillips and so on. The surface finish is quite rough, and maybe some people don't like that, but all in all I have to say that the surfaces seem to be quite resilient. The steel seems to be properly hardened, and until now, and I can say that I use these things extensively for car repair stuff and things like that, and I really have to give my thumbs up for it. I'm not sure if this wrench will hold forever. I still have like the fear that one day I might just over twist it and break it, but yeah, until now it really holds up well. What is a little bit annoying is that the steel inside actually doesn't go all the way to the end of the grip, so the end of the grip is really like very floppy. You can just twist it around. That goes both for the small as for the big one. Quite practical are also these special sockets here for spark plugs, which I really used a lot lately, and I show you what I used them on later in this video. These wrenches are also not the worst deal. I don't know exactly how much I paid, but something again between I guess 20 and 30 euros. And yeah, if you compare these, let me just show you. If you compare these to professional grade tools like this Gedore number 7, size 13, you can see that the actual form of the wrench is not as sophisticated. You know, you have this concave form in the Gedore tool, which gives it more strength at yeah, a lower weight, and you can also compare, for example, the thickness of the steel around the nut, and you will see that this is actually thinner material, even though it most probably has the same kind of stability. And yeah, I guess I could, if I wanted to, I could bend this like out of shape just by applying force to it, but as long as you don't abuse it, I guess it will be sufficient. Okay, so yeah, just talking a little bit about that and my experiences so far with these tools. Another thing that we can talk about is this circuit here, which I made really pretty much on the side. It was an idea that I had for a long time, and that was to build a sine wave generator for an inverter, for a power inverter, you know, with which you can create a sine wave AC from a battery, like a lead acid battery. And what you see here is basically just the signal generation of a periodically changing pulse width modulation that is needed to control or to drive a full bridge, or what some of you might know as an H bridge from motor controls, only that you would apply a transformer to it and not a motor. And with the help of this circuit plus a full bridge, you could, or I guess that's what I hope I could do, is to generate a 230 volts 50 hertz AC signal or power in that case from a 12 volt car battery, for example. And what I basically have done is to couple a sine wave generator to a pulse width modulation controller, and what you see here are different op-amp configurations that basically reshape the sine wave signal that is coming from the generator. So for example, this circuit here, this integrated circuit, is an ICL 8038, which is like a little bit outdated, I guess obsolete sine wave generator that was used for function generators back in the like 80s and 90s. What it does is basically to generate a square wave signal, a triangle signal, and a sine wave signal at the same time. It can do that with quite low distortion and a very high precision of frequency. You know, you trim it to a certain frequency, here 50 hertz, you know, like in the power grid in Germany. And it will give you, if you supply it, for example, with plus and minus 15 volts, and these voltages really have to be quite symmetrical, then you will get a low distortion AC sine wave out of these things. And what I did next is basically to counteract or to eliminate the DC offset to that signal that is generated by a slight asymmetrical, to a slightly asymmetrical plus and minus supply voltage. So if you have plus 15 and maybe minus 15.1 volts, the AC signal that is generated by the circuit will not be completely symmetrical, and that's why I use basically just a summing amplifier to cancel out the DC offset. After that I have a precision rectifier which basically makes a 100 Hertz rectified sine wave signal out of the 50 Hertz sine wave. And that sine wave signal is then applied to the dead time control of the pulse width modulation controller. That means that the PWM controller works without feedback in this case. That means that it would, and it is calibrated to basically just generate a pulse width modulated signal somewhere between, with a duty cycle somewhere between 0 and 100 at a fixed frequency of, let's say, 50 kilohertz or 20 kilohertz or something. And the duty cycle of the actual square waves that it generates is proportional to the rectified sine wave signal that is coming from the precision rectifier. So what it basically does is to create blocks, if you want to, it's like, how can I explain it? So okay, I have a sheet of paper right here, and I will show you what I was just talking about with a little illustration. Let's say you have an actual sine wave signal, you know, with a positive and a negative half wave, and what you do next is to rectify the signal so that you would have like the negative side of the sine wave like swapped over to the positive side. And what you do then is to give this to a pulse width modulation controller that will actually make something like this. So just that you get the idea is basically you have a duty cycle at a certain point in time, and that duty cycle is basically proportional to a sine wave, which you can see here. This is just like the proportional size. But in order to switch like a power MOSFET, you would not use an actual sine wave, but you use rectangular pulses that have a duty cycle that over time is proportional to a sine wave value. And the idea of that is, and I explained that in my SMPS tutorial, I guess it was part 2, where I tried to explain why linear regulators are not very efficient. And that is that if you have a resistive element through which a current flows and across which a voltage drops, that then always heat is dissipated and power is, or energy is lost from your electronic system. And that is something that you of course don't want in a power system like an inverter, which should have a high efficiency. And there you would use your switching MOSFETs either in the off or on state. And that is why you should drive them with rectangular pulses rather than with actual 50 Hertz sine waves. Or if you would do that, you would basically have something like a linear regulator, which would also be able to create a sine wave output, but with a very bad efficiency. And yeah, this is basically something that can be done, of course, with a microcontroller, and that's the way it normally is done today. But I had the idea for many years that I make something like an analog sine wave inverter and simply, or a sine wave generator, and simply couple it to a standard pulse width modulation controller that you can buy for like 40 cents or something. And the thing here is now that this is something that happens all the time in my projects. I have a good idea and I do it and so on. And what I build gets ready pretty quick, but then I yeah, I almost always come to problems that are almost insurmountable, and in this case the problem is that my oscilloscope is simply too bad to properly trigger a waveform like this. I mean, it's just an old analog oscilloscope, it's not possible to make screenshots with it, so I cannot really verify if the waveform that it generates looks actually like something of this kind. And you have to imagine that this picture would be representative of a switching frequency of maybe something around, I don't know, 100 or a few hundred hertz, while I'm actually switching with several kilohertz, like 10, 20 or 50 kilohertz. So it looks more something like this, okay? You have very many rectangular switching pulses that you cannot really see on an old oscilloscope like mine. I actually went to another laboratory where they had more modern digital oscilloscopes, but also of the cheap kind, and they as well weren't really able to make a proper high resolution screenshot of this varying pulse width modulation or varying duty cycle rectangular signal. And yeah, so I basically hit the wall there. I guess what I can do now is basically to build the whole thing with the power stage and then measure the actual filtered output signal that will be, if everything works, again look like something like a 50 Hz sine wave, and that is something that my oscilloscope can actually display. Okay, so much about that. I cannot tell you if there will be any progress soon or not. As I told you, I don't really know how to go on with it, with my equipment at the moment. And the next thing that I want to talk about is stepper motors. And oops, as you can see here, I have done some work recently on a set of stepper motors. And most of the smaller ones that you can see here are the stepper motors that I salvaged from the copy machine that I made a teardown of in my last video. And you can see that I added stepper motor drivers to each of the motors. You know, here you can see one of the hybrid circuits glued to a makeshift heatsink made of an aluminium sheet and some peripheral circuits around. Here you have a fully integrated unipolar stepper motor driver, and there another hybrid one, again glued on there, not really professional, but I guess it will hold. And yeah, I've basically accomplished to get all of these motors running, and I made a stepper motor driver for each and every one of them, which took me a lot of time. I guess it was like 2 days of yeah, really planning these things and soldering them together and so on. I also made these, yeah, you can't really call them discrete, but the switching elements themselves are discrete. These are really are two H-bridges with integrated motor drivers, which are needed to drive this two-phase bipolar stepper motor, while the others, by the way, are unipolar stepper motors, which can be controlled with only 4 switching elements instead of 8, even though they have like a 4-phase control. But yeah, we have to talk about these terms in more detail once I really get there. I've been using this makeshift microcontroller development board right here, which, and you better don't look too closely there, an uncovered switch mode power supply in the background. Bit dangerous in this way, but it's always at least connected to the isolation transformer, so it's not all that bad. Yeah, I've basically programmed the microcontroller with my laptop via the AVR Dragon, and yeah, with my old school C code in order to get these motors running. But yeah, and I would like to make a tutorial about the stepper motors, you know, how they work, what the different kinds are, like bipolar, unipolar, hybrid, variable reluctance, and claw pole stepper motors, what the differences are, how they work, and how you can reuse them. But yeah, to be honest, man, I spent so much time on this, but couldn't get it ready until now, and that's because, yeah, it's a vast field like anything else, and you have to make cuts somewhere. You have to make some kind of compromise with reality sometimes. I guess what I will do is to make a video about you can really get motors running that you have found in copy machines or printers, and give you like practical advice how you can reuse the motor drivers and H bridges and so on that you can already find in copy machines and so on. Because if I go in all the details and would try to explain, for example, how you can make these discrete stepper motor drivers from single components and how to lay them out and so on, I would be working like so many hours on that, you can't imagine. But I'm not sure about that. Maybe I will find an easier way than I'm thinking right now. Okay, so let's talk about the next topic, welding machines. Here you can see a Micmac welding machine that I have bought a couple of weeks ago. You could see it in the last lab report. Since then I have done a lot with it. I rewired the three-phase transformer, I made a new front panel, I bought and installed new sockets for also like using this for arc welding, which also already works. I installed a new fan inside and so on. But similar to the inverter project, I also like hit a wall here basically, and that's again, yeah, I already had to buy a lot of stuff for this machine, but there are still some things that need to be bought, and that is for the wire feeder. We need a new output connector because the old one is broken and there are no replacement parts for that. Yeah, and I need a new welding gun and stuff like that. So yeah, these are investments that I will have to make earlier or sooner or later to make this run again. Then we have like in these boxes, and you can see that it's like very messy here at the moment. I have a lot of stuff lying around because because basically of the copy machine. And you can also see like an old drum brake here, so I made a lot of work again on my car. I had to exchange the drum brakes, and that was also a lot of hassle. Yeah. Then here, what we have in here are like miscellaneous circuits of all kind, different laser units from laser printers and stuff like that. But I think I will not work on these any longer. What we have here is a Briggs & Stratton lawnmower gasoline engine, which I salvaged from an old lawnmower that I scored for free a couple of days ago. I took this like apart completely, really to the smallest pieces, cleaned everything up, and I got it running again. But it still has the problem that once it's running for like 1 or 2 minutes, it starts to smoke. You know, out of the muffler, you have like white bluish smoke, like the stuff that you would get if some of the motor oil is actually burned inside the engine, and that is of course not a good sign. I guess I can exclude problems like oil has come into the wrong parts of the engine and so on, because I removed the old engine oil before I did any work on this. I cleaned this up entirely. Every part of it was absolutely clean of old motor oil, and only once I had connected this to this or mounted it onto this board here, onto this makeshift stand, this wooden stand, there was no oil in there, so that cannot be the problem. I made really an oil change, or I've only filled in new engine oil once the thing was mounted on here. But I could imagine that either the head or cylinder head gasket is leaking, or that the piston rings are used off. This is something that I could imagine. But yeah, I don't know. Maybe you will see more about that soon. Another project that I've been working on is actually to reverse engineer this power supply unit from the copy machine. Well, I would say I put like 8 hours into reverse engineering this already, but it has been quite it has been a daring task because, yeah, it's really a complicated circuit and I still have to find out how to power up all the power supplies on there, because you basically have one auxiliary power supply that runs as soon as you connect this to the grid, but then you have the actual workhorses of this PCB inactive. So there's some pin somewhere where you need like a logic 1 to get this started up. And I already reverse engineered this PCB right here, which is basically just a common filter and active power factor correction section, which is quite interesting. And I also reverse engineered this converter right here, which is a high power forward converter, which is one of the hardest switch mode power supply topologies to make or to design. And yeah, judging from the size of the conductive path right here, you can see that it really is designed for high output currents. But as you can see also, we have like 1, 2, 3, 4, 5, 6, and I guess there is a number 7 somewhere, 6 or 7 pulse width modulation controllers on just one board. So this is really a complicated system of converters. You would, as far as I can say from now, have several also buck converters on the secondary side of the power supply. So I haven't still had the time to figure it all out, and I don't know if I ever will find the time, because I have so many power supplies I actually don't need this. And you know, you have to make a decision. If you have spent so and so many hours on a project that doesn't have so much in for you, you might just decide to make a teardown or whatever. But yeah, I don't know at this moment. And next to the power supply we have the next Briggs & Stratton engine. This is actually the Briggs & Stratton engine of one of my actual lawnmowers that I need to mow the lawn. But yeah, it has the problem that it starts up but then just switches off after a few seconds. And this has been at like a professional lawnmower repair shop, and they wanted to have a lot of money, but they still couldn't get it running really. I guess they really didn't do anything to it. It's also kind of dirty and so on. I don't think they really did anything. So that was like money thrown out of the window. And yeah, I don't know. I really can't say that I'm a big lawnmower guy or anything, but I find I have found interest in these small combustion engines lately, and yeah, I want to use one of the engines, this one or maybe that one or another one that I have like in this lawnmower over there for a little makeshift emergency backup generator that I'm going to build one day. And so yeah, you can see I've been working on a lot of projects, and some of you might be working, man, why isn't he simply concentrating on one thing and so on. It's just like the topic that I'm talking about all the time, that is like hitting walls, you know. It's you have an idea and you work on something and you maybe know how to solve it, but at a certain point in every project that I make, there is this wall that you hit and you have to overcome it. And sometimes that can happen within a week, sometimes within a month, and sometimes it takes several months, or you might decide that you cannot solve the issue altogether. So not everything that I do is a success story. It's just that most of the things that you see on YouTube are the things that actually worked. So you can imagine that there are a lot of things that you have never heard about that I've been working on simply because they were not a success story. But yeah, that's how it is sometimes. And if you're asking me what will come next as a video, it might be the stepper motor video, it might be about the Briggs and Stratton engines, might be about the power supply. I don't know, it really depends on what's going to work out first. So yeah, I hope you like this little chaotic video. And yeah, as I said, I'm going to enjoy myself a little bit in the next days, having some beers and yeah, a little fresh air and doing something else, you know. So yeah, I hope to see you soon, and I think that will be sometime at the end of the next week or so.